With limits of rational functions, there are 4 possible scenarios. So remember, a rational function is one polynomial over another. So sometimes the numerator is a non-zero constant and the denominator's limit is a non-zero constant. That's the best scenario. For example, we could have the limit as x approaches 1 of x over x plus 2. All right, that is approaching, let's see, 1 over 3. Can you write another example for me? We'll discuss tomorrow. In part B, sometimes the numerator is equal to 0 and the denominator is approaching a limit of non-zero. So let's see if I can make up an example of that. That's the limit as x approaches 0 of x over x plus 2. Actually, I can use the same function, just a different limit, because that would approach 0 over 2, which is 0. Can you write another example for me? Another option with these rational functions is that your numerator is non-zero and your denominator is approaching 0. So for example, that could be the limit as x approaches 0 of x plus 2 over x. So we see our numerator is approaching 2. Our denominator is approaching 0. Remember, if your denominator is approaching 0 and your numerator is positive, that overall limit is approaching a positive infinity. Can you write another example? And then the last possibility is that both the numerator and the denominator approach 0. How can I make that happen? So this could be, let's see, the limit as x approaches 1. Let's say that's x minus 1 on my numerator would work. And then let's say maybe x, let's say we have 1 minus x on the denominator. I don't want to do x squared minus 1 just yet. And that would approach 0 over 0, which to us is an indeterminate form. We don't know what 0 by 0 equals, and we'll discuss that later when we get into L'Hopital's rule for limits. So can you make up another example that creates this indeterminate form of 0 over 0? All right. So now in our next videos, we'll evaluate or compute some limits of rational functions.